Hello and welcome to another episode of 3-minute videos with Nathaniel. Today we will now solve question 1D of MAT Oxford 2015. We have two functions here. Now we need to find which one is bigger. Now I'm explaining this without the options, so we'll just evaluate them. Now what we can do first is that we can square the thing inside the brackets. And since x is behaves like a constant now, at least, we can drop it out of the integration, just like how a basketball player will throw the basketball on the field. And imagine this is the field, this is the constant, and this is the basketball, and it throws out. Now, what we can do is put the constant here, and the integral of x, t squared is 1 over 3 t cubed, 1, 0, equals to x squared, 1 over 3, equals to 1 over 3 x squared. This function, as we seen before, it's supposed to be 1 over 3 t cubed x 0, we ignore 0, 1 over 3 x cubed. Now we see why we ignore the 0, 1 over 3 0 cubed would have been 0. These functions look very similar, but now we're going to find fgx and gfx. It's like a function inside a function. You know those Battenberg cakes, they will have this flavor, then this other flavor, and then this other flavor, and then this. It's sort of like a mini recursion type. So what you will do, one of my favorite objects is like this Battenberg type structure, where you multiply positive and negative numbers, it crops up all over the place. And then you iterate it. You understand? It's like, take a look. 1, 2, 3, 4. It's like multiplying modulo 5, which is basically normal multiplication, except you get the remainder when you divide by 5. Alas, this may not have a Battenberg type structure, but at least you get the gist of it. You'll see 3 times 3 modulo 5 is 4, then 1, 4, 3, 2, 2. There you have it. Now I could go into like digression and relate to isomorphisms and stuff. But we will dare not go through that here because it's for the sole sake of an MAT question. fgx and gfx are two innocuous looking functions, but what is it? fgx equals to, you put the f, then you put gx. It's like, imagine a function as a machine. You put a machine before you put the output of that machine into this other machine, which will take out the output. Equals to f, gx is 1 over 3 x cubed. Now we can treat the 1 over 3 x cubed as the x here. 1 over 3 x cubed squared equals to 1 over 27x to the power of 6. Now how about gf? We can see that it's supposed to be gfx equals to 1 over 3x squared. So it's supposed to be, don't forget, g equals to 1 over 3x squared cube equals to 1 over 81x6. As you can see, gfx is exactly 1/3 of fgx. So that means we can say that gfx equals to fgx for all x. There you have it. Two innocuous looking functions with very similar function types once you evaluate the integration, and it gets murderous. And we come to a discussion between two sextic equations. And sextic equations are those with maximum power 6. And a little digression into group theory, which is one of the most interesting branches of maths in my opinion. Thank you, bye!